Hello, Miss Barber here. In this lesson titled Trigonometric Functions of Angles, we extend the trig ratios to all angles by defining the trigonometric functions of these angles. With these functions, we can solve practical problems that involve angles that are not necessarily acute. The objectives of this lesson are: 1. Be able to apply the definition of trigonometric functions to angles. 2. Be able to evaluate trig functions at any angle. 3. Know the fundamental identities. And 4. Be able to compute areas of triangles using trigonometry. Roman numeral 1. Trigonometric functions of angles. Let theta be an angle in standard position, and let the point P x, y be a point on the terminal side. If r equals the square root of x squared plus y squared is the distance from the origin to the point P, which is x, y, then the definitions of the trigonometric functions are: sine theta is y over r, which is opposite over hypotenuse. Cosine theta is x over r, which is adjacent over hypotenuse. Tangent theta is y over x, which is opposite over adjacent, provided that x does not equal 0. And the reciprocal functions are: cosecant theta is r over y, provided that y does not equal 0. Secant theta is r over x, provided that the x does not equal 0. And cotan theta is x over y, provided that y does not equal 0. The angles for which the trigonometric functions may be undefined are the angles for which either the x or y coordinate of a point on the terminal side of the angle is 0. These angles are called quadrantal angles, that is, angles that are coterminal with the coordinate axis. It is a crucial fact that the values of the trigonometric functions do not depend on the choice of the point P, x, y. Find A, the sine of 135 degrees. So we'll draw 135 degrees, which puts the terminal side in the second quadrant. And when we draw the parts, we know that this point, after you go 135 degrees, you go back x, up y, and r is the hypotenuse. And the sine of 135 degrees here will be y over r, which is exactly the same value as sine of 45 degrees, because for 45 y is also positive, and the sine of 135, which is the sine of 45 degrees, is the square root of 2 over 2. Now, let's look for the tangent of 420 degrees. Let's put this in the first circle. So if I subtract 360, I'll get that the tangent of 420 degrees is coterminal with a tangent of 60 degrees. Let's draw that angle. So up 60 degrees. Then we know that the tangent by definition is the opposite, which would be y, over the adjacent, which is x. And we know that the tangent of 60 degrees is the square root of 3. And finally, let's look at the cosecant of 390 degrees. Again, let's put this in the first revolution. So if I subtract 360 degrees, I will get that the cosecant of 390 degrees is equal to the cosecant of 390 minus 360 is 30 degrees. And we know that the cosecant is defined as the hypotenuse over the opposite, and this is the reciprocal of the sine function. The sine of 30 degrees is a half, so the reciprocal of that will be 2. Roman numeral 2. Evaluate trigonometric functions of any angle. Complete the following table to indicate which trigonometric functions are positive and which are negative in each quadrant. In quadrant 1, all trig functions are positive, and so that also tells us that there are no negative trig functions.
In quadrant 2, the sine and its reciprocal cosecant are positive. That means the remaining four functions, the cosine, secant, tangent, and cotangent, are negative. In quadrant 3, the tangent and its reciprocal cotangent are positive. That then tells us that the remaining four functions, sine, cosecant, cosine, and secant, are negative in the third quadrant. In quadrant 4, cosine and secant are positive. Then the remaining four functions of sine, cosecant, tangent, and cotangent are negative. A helpful mnemonic device is to consider the axis in the counterclockwise direction, and starting in quadrant 1, think of all, as in all functions are positive. In quadrant 2, think students, or S as in sine and its cosecant, are positive. Continuing in that direction, in quadrant 3, think the word take. T as in tangent and its reciprocal cotangent are positive. And finally, going all the way back around to the fourth quadrant, calculus. C representing cosine and its reciprocal secant. That is, all students take calculus.
Let theta be an angle in standard position. The reference angle, theta with a bar over it, associated with theta is the acute angle formed by the terminal side of theta and the x-axis. To find values of trigonometric functions for any angle theta, 1. Find the reference angle theta associated with the angle theta. 2. Determine the sign of the trigonometric function of theta by noting the quadrant in which the theta lies. And 3. The value of the trigonometric function of theta is the same except possibly for the sign as the value of the trigonometric function of the reference angle. Find the reference angle for A, 210 degrees. Let's draw 210 degrees in standard position. That would be in the theta equals 210 degrees, would put the terminal side in the third quadrant. The reference angle is the distance from the terminal side to the closest x-axis, so we would end up doing 210 degrees minus 180 degrees, and the reference angle would be 30 degrees. Find the reference angle for part B,
which is 675 degrees.
Let's put it within one circle, so I'll subtract one revolution, that's 360 degrees, and what we'll have left is 315 degrees. 315 degrees is coterminal with
675 degrees.
Let's draw 315 degrees. When theta is equal to 315 degrees, the terminal side is in the fourth quadrant, and the reference angle, theta with the bar over it, is the angle between the terminal side and the closest x-axis, so that'll be 360 degrees minus 315 degrees, so the reference angle is 45 degrees. Roman numeral 3, trigonometric identities. Complete each of the following fundamental trigonometric identities. 1 over sine theta is equal to cosecant theta. 1 over cosecant theta is equal to sine theta. 1 over cosine theta is equal to secant theta. 1 over secant theta is equal to cosine theta. Sine theta over cosine theta is equal to tangent theta, and cosine theta over sine theta is equal to cotangent theta. And then we have the Pythagorean identities. Sine squared theta plus cosine squared theta equals 1. Tan squared theta plus 1 equals secant squared theta. And 1 plus cotangent squared theta equals secant squared theta. These should all be committed to memory. Express cosine x in terms of sine x for x in quadrant 4. Let's begin with the Pythagorean identity of sine squared x plus cosine squared x equals 1, and we'll solve for cosine. Then cosine squared x is equal to 1 minus sine squared x, and using the square root property, cosine of x is equal to plus or minus the square root of 1 minus sine squared x. Now let's go back and pay attention to the fact that x is an element of quadrant 4. And in quadrant 4, cosine is positive. So cosine x in terms of sine in quadrant 4 is the positive square root of 1 minus sine squared x. Roman numeral 4, areas of triangles. Let's observe the triangle drawn. The vertices are A, B, and C, and we are concerned with the interior angle C for the purpose of this formula. Let's recall that from basic geometry, the area of a triangle is 1/2 times the base times the height. So let's go back to the triangle. If the interior angle is C, we can extend it through drawing a complementary line and say that C bar, which is the reference angle, is 180 degrees minus C. So let's note the sine of C bar is equal to the sine of C, and sine is opposite over hypotenuse, and so the opposite is the h we have designated as the height, divided by b, the side of the triangle. Solving for h, we get that h, which is our height, is equal to b times sine c. Now let's go to the trig form. The area of a triangle with sides of lengths a and b with included angle capital C is given by a equals 1/2 a times b sine c. Let's note that b sine c is the height of the triangle. Find the area of triangle ABC with sides length C equals 8 centimeters, A equals 3 centimeters, and interior angle B of 150 degrees. So let me attempt to sketch this triangle. It will not be accurate, but I'll label it correctly. So we'll do short side, long side. The interior angle is B, and that is given as 150 degrees. It doesn't quite fit the drawing, but that's okay. We have the opposite side of vertex A is little a, and that's 3 centimeters. Okay. Opposite side of vertex C is little c, and that's 8 centimeters. And we want to find the area of the triangle, which is 1/2 A times B, the length of the sides, times the sine of the interior obtuse angle this time. So it's going to be 1/2 times A was 3, B is 8, and sine of 150 degrees. So I'll do these three. 3 times 8 is 24, and half of that is 12. Sine of 150 degrees is the same as the sine of 30 degrees, which we know is 1/2. So 12 times 1/2 is 6, and the area would then be 6 units squared.